On, please turn on camera.
Can I have some waters?
Sure. Even you can leave for a while if needed. So we already finished the first two chapters, which was about the function, limit, continuity, and derivative. And today we start the third chapter, application of derivative, which will be lasting for 2 weeks, which means after finishing of the chapter 3, we will pass the half of semester. Then there will be a midterm. The timetable of the midterm will be announced by the Department of General Education in the future. But please pay attention. First, I will be announcing when I get the exact time for the midterm on Moodle and officially announce about the topic. However, today, you should know that for the midterm, the topic is on 3 chapters, chapter 1, chapter 2, and chapter 3. And the time allowed is 1 hour. Okay. Next, we already passed more or less almost half semester. I mean, in 2 weeks. And that's why more or less you are already familiar to the teaching way I am conducting, to my explanation in Vietnamese. And from now on, we try to reduce speaking in Vietnamese. I will explain sometime only. And most of the time, we have to study, listen to me, speak to me, discussion with me only in English. This is a requirement, okay? So because already how many? So 4 lecture up to now, we have so many hours. You study with other the lecturer also, then it's time to speak only in English. Okay, so in the second semester, no Vietnamese at all, because in the second semester, we most probably will be having some real foreign student. Okay, so now, before starting this chapter 3, as usual, I would like to remind you that after each lecture, after the Thursday lecture, as the latest on Friday, I always upload the summary for the previous lecture, and it helps you to revise what you have studied previously. Especially, it also helps you to understand the topic you have to do for tutorial problem. I already talked to the tutor, and I hope they will be taking into account your feedback. Especially, I asked them not to go through all tutorial problem. Instead, they should select some important tutorial problem to discuss with you, because what you need is the way of thinking, the solution technique, than going through our own the tutorial, because each time I give you quite many. Oppositely or conversely, you can also raise your hand during the tutorial, 2-hour tutorial, and ask the tutor to discuss about this or that specific problem. You have such a right. So don't hesitate to ask tutor to do so. Okay. And now we start chapter 3. Chapter 3 is about application of derivative, and more or less several topics in this chapter you already study in your high school, and it is good. It's good. Okay. So here, if you look at the topic of this chapter, you see more or less the first four sections you know already. Very important is optimization problem. Here, as I wrote, you have to find the optimal solution, or it means the best solution. Then the derivative will help you to do so. After that, you have the other section, which is Newton method. This is approximation solution, not exact solution, because in engineering, in many problems, you cannot find exact solution. So instead, you work on the approximation. And the last one, antiderivative, we also already studied. This related to the preparation for the integral. Okay, that's the thing. So today, our task is the first four parts. Okay. So what do we have? Maximum and minimum value. If you look at the figure like this, you can see the graph at a point 3 and 5 is highest on the graph, and at the point 6 and 2 you have the lowest one. So in this case, on the interval from 1 to 7, that interval, you have f at 3, which is 5, as the absolute maximum, and f at 6 as 2 is absolute minimum. Okay. So if someone have to keep the lesson, yeah, it's okay for the jab of the vaccine, COVID-19, you can go. Yes, so then we have a definition which you know quite well. If you look at the domain of a function on some domain, and you see that the value of f at c, or we can say evaluation of f at a point c from D, is the maximum absolute, which means no value of fx on D is bigger than fc. That is, fx is less than or equal to fc for all x from D. Then you have absolute maximum. Similarly, you have absolute minimum, which means f at c is the smallest. No value of fx is less than fc. So here you have the word absolute. Sometimes they also replace this by global. In overall, you have on the domain. It is different from local. Local means you look at a part, some part of a domain. So for example, if you look at the absolute maximum and minimum of over all of Vietnam, then we have the country maximum, country minimum, I mean in some sense. But if you look at only Hanoi, then it is local, because maximum or minimum in Hanoi doesn't mean that maximum, minimum in over the Vietnam, right? That the local and global. So that we already talked about. And in this case, because you have a maximum and minimum, sometimes they call both at extreme value. Extreme. Okay? The word replace extreme mean either maximum or minimum. Okay? So in this case, you see, if you have a graph like that, you can see this is the value of the absolute minimum, and this is the value of absolute maximum, right? So by our definition. But if we look at a value, for example, near B, for example, that interval, that is, you have this one, right? This one. Then f at B in this case is a largest value on that interval AC. So, but at B is still less, much less than f at D. So, however, on that local path, you have the maximum, and in this case, we call this as a local maximum, exactly as I just explained to you, to compare between Vietnam maximum minimum or Hanoi maximum minimum. So we have a global and we have a local. Okay? The same, if you look at C, you have in this case the local minimum. Local minimum. Here also local minimum. In comparison with that one, the absolute minimum. So it depends on the interval you are considering. And even if you look at the whole part A and E, you still see the local minimum at several points. And there are several local minimum in this case, right? But they are not the absolute minimum. The same for the maximum. So then, from that, we have a similar definition. Local maximum and local minimum. If you have the same inequality as the absolute maximum and absolute minimum, don't look at the whole domain, because on the whole domain you have already global or absolute maximum and minimum. Okay, so that on some local part you can have the definition of maximum and minimum. So that's why we say near C here. We mean that some open interval containing C, as we mentioned on the previous that one, right? You look at AC, you look at AD is the same, or you look at C and E, all are local, not the whole interval you are considering. Okay, so then we want to ask, when does a function have the extreme value, have maximum or minimum? And here, one of the results you should remember, if f is continuous, pay attention, on a closed, so these two important properties. interval you consider is closed, which means that you take both n, a and b, and f is continuous on that closed interval, then you can have both absolute maximum and absolute minimum on this interval, which means you always have some c for which fc is the biggest value of fx over ab, and you have some d for which f at d is smallest in comparison with own value fx on the interval. Here, remember, no differentiability is required, only continuity, but instead you need closed interval. You need closed interval. Okay. So only continuity, but you need the closed interval. Then we can say a continuous function on a closed interval can always attain maximum absolute and minimum absolute. Right? So that important theorem you can use. So in this case, you see, when a function you have continuous means that you have the graph from one point to another point without taking out the pen. In this case, you see, always you have absolute maximum and absolute minimum because we consider the value of the closed interval. Pay attention on this closed interval. Okay. So more than that, you can see the function can attain extreme value more than once, which means that there might be some value at some point, C1, C2, C3, for example, at which f at C1, f at C2, at fc3 all are equal and all are absolute maximum or absolute minimum. Okay, so that very important to note that. So here, two conditions, continuity and closed interval in the so-called extreme value theorem are extension, which means that you cannot, in general, remove either of these two conditions. If you have no condition on that, or only one condition is satisfied, the other not, then in general, the extreme value theorem is not true anymore. Okay, so that here, the function not continuous on the interval 0, 2, right? And you can see if you look at that, you can have value, how about value 3, see? Not belong to this point, value is that one, right? Not 3. Never attain the value 3. But here the same, because you have 0, 2, but not close at 2. 2 is not included. Then you even don't have the maximum or minimum if you look at the interval 1, 1. I mean that one, see, to infinity. Value you have here, never get it. So that's why continuity and closed interval are needed in this extreme theorem. Okay. More than that, this extreme value theorem doesn't tell you how to find this value. You see, the statement is, if you have continuous function on the closed interval, then you have absolute maximum at some point C, you have absolute minimum at some point D. How to find C and D, you don't know. You can be sure only that they exist. So that's the weakness of the extreme value, right? So, however, we can start with this problem to see how to solve it, how to find the extreme value in some cases, step by step. The first one, the so-called Fermat theorem. So Fermat, you know that guy, right? It's for about 400 years, the big problem, big theorem of Fermat. No one could solve it. And finally, it has been done for very complicated and very high level, the proof, mobilizing a lot of knowledge. But at Fermat time, he wrote on the book, very narrow margin, that is too small for him to write the proof, but he claims that the theorem is true. So that means that equation AN plus BN is CN, when ABC, the integer, so n bigger than 3 or equal, cannot have the solution. But only after several hundred years, people could solve it. That's interesting. And here, what his theorem is talking about. First, if f has a local minimum, f has, suppose you know that f has a local minimum or local maximum at an interior point. Interior point means that not the end point. Okay. C, in the domain, and if f prime of C exists. So you see, in comparison with the extreme value theorem, there is no differentiability is involved. But here you need that. You should have the existence of the derivative at a point C. If you know f has a maximum or minimum local is needed only. No need to talk about the absolute maximum or minimum. So then, if this point is interior point and you have the derivative, in this case, you have the conclusion that this derivative must be 0. So you look at that. F prime of C equal to 0 means that the tangent line to the graph is parallel to x-axis. See, this parallel to x-axis, this parallel to x-axis, because f prime of C is the slope of the tangent line to the curve at a point. So this tangent line must parallel to the x-axis. That the illustration on the graph of Fermat theorem. Okay, so but remember, the converse of Fermat theorem is not true in general, which means that if f prime at C is 0, you cannot in general say that C is a point of maximum or minimum. Not that, only one direction. Okay? So here, for example, you consider fx cubic, very beautiful function. This function is defined everywhere on the real line. Continuity everywhere, differentiable everywhere. But when you look at f prime of x equal to 0, you have x is 0. This is a point C. But point C is neither local maximum nor local minimum, although the derivative is 0. So that's why the converse, this direction, is not true in the Fermat theorem. Okay, which means this Fermat theorem gives you a necessary condition for the local maximum or minimum. If you have a local maximum or minimum at a point and derivative exists, then the value of derivative at that point must be 0. One direction only. Okay. So this also allows us to find the maximum or minimum, at least. So if you want to find at an interior point, you should solve the equation f prime x equal to 0. Because if it exists, you look at this point and consider, investigate which point can be local maximum or minimum. If f prime of x is non-zero, by Fermat theorem, you cannot have such the local maximum or minimum. Okay, so here we talk about the counterexample. Horizontal line, yeah, that's the meaning. Okay, now look at other example. Victory function, we know from the beginning. So how about this function? This function f is continuous everywhere, differentiable everywhere, but 0. So remember this English way. Something satisfies everywhere but 1. But here means that except. That's the way in English. All of you are free today but 1. Which means that all are free except 1. Or all are attending but 1. All are here except 1 student. So pay attention on the way. In this case, you see where the local minimum? No, right? Derivative. But the local minimum or even absolute minimum exists. See? So which means you need the local maximum or minimum at a point C, and you need f prime at C. Both exist. Then you get f prime of C is 0. But here you don't have that. You have only local minimum. So you cannot say that f prime of C is 0, right? At 0. See, you need. So from this result, overall, I want to tell you, when you have the coming midterm or final exam, before apply any result, theorem, proposition, lemma, etc., you should be sure that all assumptions of that result are satisfied, of that theorem are satisfied. You have to check all conditions. After that, you can get the conclusion. without checking whether all assumptions of a theorem satisfy or not, you cannot say anything. Okay? So that's why you have to be very careful when using Fermat theorem. So to characterize the point at which we talk about the derivative in interior point or not, you have the following definition and pay attention. I don't know whether in Vietnamese we have the word on that. If you have an interior point C of the domain at which either f prime at C is 0 or f prime at C doesn't exist, then in both cases we can't see a critical point. We can't see a critical point. This critical point means you have a point at which derivative is 0 or at which derivative doesn't exist. So this case, for example, the function modulus of x at x equal to 0, right? Doesn't exist, f prime. 0 belongs to the domain of this absolute value function. So then it is a local minimum, we know. However, we don't talk about minimum or maximum, we talk about classification of point. This point belongs to the category of critical point. So here, if we talk about this at one part, f prime of C is 0, then Fermat theorem can be rephrased such as if f has a local minimum or maximum at an interior point C, then C is critical point or critical number of fx, which means then f prime of C either equal to 0 if exists or doesn't exist. F prime, right? Okay, so here, only point in the domain are assume extreme value, which means we want to look at maximum and minimum. Then two class of point you have to consider. First, critical point. Because critical point are about interior point. So this is the first category. The other category class is endpoint. So on the interval AB, you look at A and B as the endpoint, and you look at a point inside the open interval AB. So two things you have to do, because remember, this theorem talking about interior point, not about endpoint. So you should include endpoint in finding extreme value. Understand? So now, for that case, when you could find extreme value in local meaning, we now can find the absolute maximum or absolute minimum for function continuous on the closed interval. We already mentioned the extreme value theorem gives the conclusion that a function continuous on a closed interval has maximum and minimum, but you don't know where they are, this point, or you don't know how to find this point for maximum value and minimum value. But now you can have it. You can have it using the derivative. So you see the closed interval method. Pay attention. This closed interval, close unit, right? For function continuous on a closed interval, by the extreme value theorem we talked about from the beginning, there exists maximum, minimum, absolute. Because we talk about the local, but now we claim that there exists maximum and minimum, absolute. How to find? This method gives you the way to find. First, you find own value of f at critical point on AB. Critical point on AB interval open means that f prime of x equal to 0. You find own x from the open interval AB for which f prime of x is 0. And then you look at the endpoint. So the endpoint, you also find value. And own value at the critical point and at the endpoint, you compare and take the largest, you have absolute maximum, the smallest, you have absolute minimum. So here it means in comparison with the extreme value theorem, you find the absolute maximum and minimum using the critical point inside the open interval and endpoint of that interval. You need that, okay? So this is the closed method closed interval method. So for example here, you have the interval closed -1/2 and 4. This is closed. And you are asked to find the absolute minimum and absolute maximum. Function polynomial continuous on this closed interval, then by the theorem, you should have maximum and minimum. And now even you can find the absolute maximum and minimum by the following method. First, look at the value at critical point and then value of at endpoint and compare them. So first you have to find the critical point before you have the value, right? F prime equal to 0, then you have x equal to 0 and x equal to 2. And 0 and 2 are in the interval 0, 2, 4, -1/2. So you have this interval. And these 2 points, 0 and 2, are interior point. So at which f prime is 0, you have critical point. Now you find the value of f at these critical point, which are 1 and -3. Okay, the first step done. Next step, value at the endpoint. The value at the endpoint is f at -1/2, which is 1/8, and f at 4, which is 17. So now you compare 1, -3, 17, 1/8 to see which one is biggest. This biggest. And which one is smallest? This smallest. This smallest. -3. Right? So this means f at 2 is -3, give you the absolute minimum. And f at 4, which is 17, give you the absolute maximum on this interval, closed interval. Okay, so such a thing. Very interesting and easy to work on this method. Okay, next, after understanding the existence of local or absolute maximum and minimum, several theorems we already talked about, we move to the second point, the mean value theorem. Mean value theorem. Okay, so remember MVT here means mean value theorem. You also have IVT. So what is IVT? Here MVT, they are different. So here we already talked about. Who can tell us what the IVT is? Vũ Quỳnh Anh B1-12-019. What is IVT? Do you remember?
I think I forget about this.
At the end of chapter continuous, it means that last chapter, very recent. Nguyễn Khang 020. Do you remember what the IVT is?
No, I don't remember very well.
Who can give who raised the hand? Who wrote which one? Nguyễn Nhật Anh. No, Trịnh Tiến Minh already wrote about that, right?
Yes.
Intermediate value theorem. Yes. Intermediate value theorem about if a function is continuous on some interval AB, for example, then it can receive any value in between FA and FB, right? That IVT. So please pay attention on the brief of the name of theorem and also remember the statement of theorem. So they are different. IVT and MVT. IVT for continuity, MVT for differentiability. Okay, so now we look at that. Mean value theorem is very important in calculus, which means that very important for engineering problem. There are two cases in this mean value theorem. First, simple case, special case, we call Rhone theorem. So, what is that? A function for Rhone theorem must satisfy three conditions. Remember, three conditions. A function is continuous and the interval is closed. So, only by the first condition, by the extreme value theorem, you can conclude that this function f has extreme value, has maximum and minimum on the interval AB, right? At least continuity give you such a thing on the closed interval. Next, but in this Rhone theorem, you have more assumption. F is differentiable, which you see imply continuity, but differentiable on the open interval AB, which means that at the end point A and B, we don't talk about differentiability. We don't know and we don't care. We don't care whether f has derivative at A and at B or not. In this case, of course, one side derivative, right? On the right of A and on the left of B, don't care. You look at the differentiability on open interval. But because f continuous, which means that define on closed, we can talk about the value of f at A and f at B. Value you can, because a function continuous on that, it means that it's defined well. Differentiability don't talk about. We don't know. Maybe not, but value, yes. If you have the value are equal, then From these three conditions, you can conclude that there exists a number C. There is a number we understand at least one. We don't talk about how many, but there is a number, which means that at least one number C at which f prime of C is 0. A C in the interval open, which means that f prime of C is slope of the tangent line. In other words, if you look at that, a function continuous on the interval AB, C including 2n. The second, everywhere on the interval, you can have the tangent line everywhere on the open interval. This is the second condition. The third condition, these 2n, the value are the same. Then f prime of C equal to 0 means that there exists a point C at which the tangent line has a slope 0, which means that tangent line is parallel to the x-axis. See? On that one, only one point C. On the other, you have 3 points C, which means that on this curve, you can find a point at which the tangent line are parallel to the x-axis. This is Rhone theorem. Okay, so here 1C, here more C. That's the meaning. Now example. You are asked to prove that this equation has exactly one real root. So look at that exactly, which means that one and only one real numbers at which you have the left-hand side function is 0. You cannot have more than one, exactly one. And from the high school, your teacher in high school should already talk to you. If a polynomial or curve is of degree 1, 3, 5, 7, which means that odd degree. Then polynomial of odd degree has at least one real root. At least one real root. So for example, here you see x cubic 1. But at least means that maybe more, right? So, however, in this case, you are asked to prove that exactly 1. And now how to do? First, IVT, intermediate value theorem, we just mentioned, tell us that root exists. Why? Because if you look at x tending to negative infinity, then fx is negative, because this is very, very big x cubic with negative sign. If you look at positive, you have fx is positive. Then between positive and negative, there is a 0. So that's why root exists. Okay? Or even very simple. You look at the f negative 1, which is what? F negative 1 is negative 3, less than 0. F at 2 is 9, right? Positive. Then between negative 1 and 2, you should have any value, including 0. That is, you have a root. Good. This is intermediate value theorem. Next. Now you see, at least you can look even at that case. Very easy in comparison when I talk to you, right? I talk to you, you take negative 1 and 2, and here 0 and 1. you have. But for this case, you see if you take 0 and 1, you have a C is interval of 0 and 1, which means that there exists a number C in the interval open 0 and 1 for which FC is 0. Yes, the same as we talked about. There exists a root. But now, using the Rhone theorem, you have to show that no more root except that one. And how to prove by this Rhone theorem? You prove by contradiction. Here, assume. Remember, when you use contradiction, you have to use the word assume. It's better than suppose. Suppose, more or less, you have the affirmative assumption. But assume means that assume in contrary. Giả sử ngược lại. Đấy. In contrary. Assume chúng ta có two root A and B, which means that FA and FB are equal and 0. A less than B. So, this F is polynomial, satisfy the first one, satisfy the second condition, polynomial is differentiable, and satisfy the third condition, FA, FB are equal. Then, there is a number inside the interval for which f prime of C is 0. So, but f prime of Cx is 3x squared plus 1 bigger than or equal to 1, which means that it is never 0. Contradiction. You have the Rhone theorem saying that there is a point at which f prime of C is 0. But in reality, f prime of x is never 0 for any x. Why you have such a contradiction between this and that? Because we assume that f has two roots. Your assumption is wrong. So you cannot have such assumption. That is either no root or one root. Cannot be two or above. But we already talked, yes, there is a root. There is a root. Then cannot be no root. So one, and exactly one root for this equation. Okay? And it is that. Very interesting. You have intermediate value theorem. You have now, and you have the Fermat theorem. Then you have Rhone theorem, right? Already 3 theorem you can have. And now short break, 10 minutes, and we continue to talk about other theorem related to the application. Short break.
Sorry, Professor.
We continue our lecture. So we already used the Rhone theorem to show the contradiction. If we have two roots, then we cannot have two roots, which means either no root or one root. But because already there exists a root, we show by IVT, then we get exactly one root. Usually such a problem given for the midterm or for the final exam is always difficult. But you have to show there exists a root, and the next step, this root is only root you can have. That two part in such a question. Okay, so now you move to the next one. This is really MVT. MVT, the mean value theorem. So who now turn on the microphone? Let's see. Who turn on microphone? And who that? It seems Lê Linh Chi, right?
Yes, that's right, I think.
Professor, can you mute? Okay.
Oh, yes, I mute her. So, Lê Linh Chi, why did you turn on a microphone with music? That another question. I remember the first time one girl talking at the end, we already talked about, and now the other girl. So pay attention. I 10 minutes means that 10 minutes. Even you should be careful and ready before that. Okay. So, and now we talk about the mean value theorem, real MVT. What is that? You have the so-called MVT in many textbooks. They write just MVT, but we may have more precise Lagrange mean value theorem. Lagrange, the name of the French mathematician. Okay, so what do we have? In comparison with the Rhone theorem, you have only first two conditions. F is continuous on closed interval and F is differentiable on open interval, only two. Then there exists C in the open interval AB such that F prime of C is equal to the ratio FB minus FA over B minus A. This is the same is you take FA minus B, but in this case, you should change to the same A minus B in such an order. Or you cross multiplying, you get this one. What's the difference between two? Here, at least, you look at interpret geometrical. When you don't have FA and FB are equal, then you have a second, tức là cái đường cát tuyến. And there exists C for which at this point, the tangent line is parallel to this one. You see the same, that second, and you have 2 points even. But in case this become that case, equal FA and FB, then the tangent is parallel to this, means that parallel to the x-axis. That is, when you have this theorem, mean value theorem, Lagrange theorem is more general than Rhone theorem. Because if you have the third condition, FA equal to FB, as the assumption of the Rhone theorem, then it becomes 0, right? It is 0. And you get F prime of C is 0, exactly the Rhone theorem. Which means Lagrange theorem implies Rhone theorem. But we use Rhone theorem to prove the Lagrange theorem. That's the thing. Okay? Here, You understand the slope, and I already explained, means that the tangent is parallel to the second AB. Okay, so and exercise, you look at that as physical interpretation. You have a car speeding, accelerating from 0 to 8 seconds. After 8 seconds, it passed 176 meters. But in this case, we have, because car is accelerating, you have the average. Average means this different from instantaneous, right? Instantaneous at vận tốc tức thời tại từng điểm một. Còn cái average là vận tốc trung bình. Over the 8 interval here is 22 meters per second. But of course, you understand that not at every second you have such the velocity, because it's increasing. Instantaneous is different from average. At each point you can have velocity from time to time higher and higher, but average is 22 meters per second. And you are asked to use the mean value theorem to show that you have, if you look at the speedometers, cái công tơ mét khi mà các em accelerating cái car, you should have a point when you see exactly 70.79.2 kilometers or the same at 22 meters. See, you look at this ST velocity, and you see velocity is increasing from 0 to 8 seconds, from 0 meters to 176 meters. And from at any point, you can have instantaneous. But then you have to show that at exactly one point, you get precisely such an average velocity. Do it, and you understand very nice the physical interpretation. Các em bắt đầu xuất phát từ 0 cho đến 8 giây thì thế nào cũng có cái lúc mà cái speed car của các em sẽ đạt được 79,2 km/h, có nghĩa là đúng cái thời điểm đó là cái instantaneous nó bằng cái giá trị là vận tốc trung bình trên toàn bộ cái khoảng 0,8. That you have to use mean value theorem, and you see, as I talked from the beginning, the mean value theorem in particular and other results in this section are very important in engineering. Okay, so, and as a consequence, we have two interesting consequences. First, if a function is differentiable and its derivative vanish at any point. Vanish means that equal to 0. So f prime of x equal to 0 for any x from AB. Then f is a constant. F is a constant. So very easy to prove. If you have fx1 and fx2 minus x1 minus x2 is some fc, right? And if fc is 0 because c inside, then f1 and fx1 and fx2 are equal. That is, everywhere the value of f is the same. That's why you have a constant. Very simple proof using the mean value theorem. The other result is, if you have two functions whose derivatives are equal for all x, then their difference is a constant, or they are differ by a constant. This is very important for antiderivative, for nguyên hàm mà các em học, for integral, indefinite integral là tích phân bất định. We talk about later. That, and how to do? You consider the difference hx is fx minus gx. Then you have h prime of x is 0. And you apply the first theorem to get h is a constant. That is f and g different by the constant. And you get the second theorem. Both are very simple proof. So that's why I didn't mention here how to prove that. I explained to you. But pay attention. You have to be very careful to apply theorem, which means you need to verify own assumption. Here, for example, if you look at this function, define everywhere except 0, right? And you can see for x positive, you have fx is 1, then derivative is 0. For x negative, fx is negative 1, derivative also 0. But D here is real life, remove 0. Then you have fx is equal for all x always 0. But f is not a constant function, not a constant, right? So fx like that. For positive x, for negative x, that's all. Here, f. Not constant, although f prime is 0. So that's why, because whole interval except 1 point. This is not interval we talk about. This is already union of two intervals. Negative infinity and 0 to plus infinity. They are different. So pay attention. Here we talk about one interval AB, interval 1 interval. Then you can have it. Right? Next, contradict because not an interval. Yeah, I already explained. So, okay. And now, after having mean value theorem, and remember, you have Rhone theorem and you have Lagrange mean value theorem. We look at the derivative tests, which are quite familiar to you, When you study, you prepare for the examination of high school, right? So what we can talk about here, first, look at this. You can see the function increasing, decreasing, and increasing. And it depends on the tangent exists, and at each point you can see depend on the value of the tangent, right? Value of the tangent slope. So which means you have a derivative. This one derivative positive, that part derivative negative, slope. This is slope, right? Okay, tangent of the slope at each point. That's the reason we have the test. How to test whether a function is increasing or decreasing on some interval. So you look at the derivative. And usually when you look at this interval, right, you have f, you write like this, up arrow or down arrow. Here, this down, right? So, which means that increasing or decreasing depending on the sign of the first derivative. So no problem with that. You know quite well this situation, which means you have the first derivative test. Remember, you have first derivative, which use the first derivative. You use the first derivative, then you have the first derivative test. If A point C is critical point. Lê Linh Chi, what is critical point? Lê Linh Chi đâu rồi? Như vậy là cô này, cô ấy bật máy lên, không show mặt và đi chơi. Tức là bật music, có khi bây giờ tôi bật lên, có khi music nó vẫn kêu cũng nên, hay là hết rồi, tôi đã mute đi rồi. Và bây giờ tôi hỏi là critical point là gì? Chả thấy cô ấy đâu cả, cô biến đi điểm nào? Đấy, lần trước là cô gì? Cô Thu Giang, lần này là cô Linh Chi. Cô Linh Chi, đúng rồi, Lê Linh Chi. So, ai ở lớp mà có Lê Linh Chi thì warning bạn về cái điều ngày hôm nay chúng ta đang nghe đây. 1 là bật micro, 2 sau đó đi chơi, 3 là thầy hỏi không biết đằng nào cả, 4 không turn on camera. Đấy, again, một người nữa xuất hiện. Đấy là lý do tại sao tôi yêu cầu các em là turn on camera. Nếu các em thấy các em không học, ai mà cứ xin tôi ra ngoài mấy phút, ok, no problem, không có vấn đề gì cả. Đối với tôi chuyện đấy là chuyện đơn giản, các em có thể ra chuyện nọ chuyện kia, các em phải làm những necessary things during my lecture. Because this is online, you can go. Even you don't have to ask me, I allow you. But after a while, I ask someone and I don't see them, which means that left without attending, without asking. But if you ask, it's okay. At least let me know you want to go out and you write, I want to go out. It's okay. I didn't answer, but I am okay with that. Okay. Yeah. Here, critical point we know, right? Right? Okay. So critical point is very important. And that's why critical point, which is at a point you have derivative is 0 or doesn't exist. If it belongs to the domain. And because of that, on the left or on the right of this C, you can have different sign. If equal to 0, on the left you have plus, go to minus, then you have maximum. But if you have from minus to plus, you have minimum, here maximum. But if you don't have any change of the sign, then no local maximum or local minimum. Like x cubic plus is x cubic, right? At x equal to 0, you have critical point. But f prime is x squared, always positive for x less than 0 and for x bigger than 0. So no sign change. Then x equal to 0 is not a local or maximum or local minimum, right? So here you know from your high school that the first derivative test, that here when you have increasing and then decreasing, you have maximum. You have decreasing and then increasing, you have minimum. But in that case, you see, like x cubic, you have critical point, but on both sides of this point, you don't have the different sign. The same here. If you take negative x cubic. So in this case, you don't have maximum or minimum. Okay. Example, no problem. Very simple. You look at this function continuous everywhere, differentiable everywhere. On this interval, you look at the critical point, which are 2 pi over 3 and 4 pi over 3. You consider the function at this critical point, and you look at the derivative of gx before x equal to 2 pi over 3 and after, before 4 pi over 3 and after, then you get such the table. And on that, you can have, so when you write like that, right, this is maximum. But if you have this situation, you have the minimum. Yeah, quite simple. From your high school, you already know. Okay. And the graph of Z like that, very beautiful. X plus 2 sine x. So now another thing we can have to face, even on this case, when you have a function increasing, but they bend in different direction when you go from A to B. Tức là hai cái đồ thị này đều là đồ thị của một cái hàm tăng. Đồ thị đều đi lên. Nhưng mà cái độ cong của nó khi đi từ A đến B là different. The left one, you see, from A to B, it bend. The graph is bending, but on curve like above tangent. Đối với hình bên trái, các em thấy là đồ thị bao giờ cũng nằm ở trên cái tiếp tuyến. Hàm tăng đấy, nhưng mà đồ thị nằm trên. On the other hand, the right figure, the curve always lie below the tangent. Đều là hàm tăng nhưng mà một bên là đồ thị nằm trên các đường tiếp tuyến và một bên là đồ thị luôn nằm dưới các đường tiếp tuyến. So they are different. Then how to characterize the interval on which the curve lie above the tangent line or below the tangent line? For this case, we need double right the second derivative to use. So before that, we have a definition. If the graph lie above of all tangent line on some interval like that, graph lie above tangent line, every tangent line on this interval, then we say that the function is concave up or upward. Cái này tức là cái từ concave là hàm lồi, còn có cái từ hàm lõm là convex. Convex là hàm lồi, concave là hàm lõm. Lồi lên trên và lõm lên trên, lồi xuống dưới và lõm xuống dưới. Thì it depend on the graph lie above or below. Because if above tangent line, right, you have such a thing. Then các em thấy không? Rõ ràng là nó cong và nó cong đi lên như này. Đúng không? Up. But this one là nó cong và nó cong đi xuống. Because graph is below tangent line. So that's the different thing. And we have upward or downward. Đi lên hoặc đi xuống. Okay. So that's the thing. Yes. Anyone want to ask? No, right? So in this case, you can just the upward or downward on this interval AQ by different part I wrote here. Okay. So now we use the second derivative to characterize the concavity. Concave is adjective. Concavity. If you look at convex, then convexity. Danh từ là convexity và concavity, còn tính từ là concave and convex, lồi hay là lõm. Okay, so here, upward, yes, I already explained. When you have both sides are up, but here both sides are down, you have concave down. Okay, so then for this one, you can see the left F right is increasing. The slope of the tangent line increasing. But on the right hand side, the slope of the tangent line is decreasing, and in both cases you have either positive second derivative, because f double prime positive means that f prime is increasing. F double prime is negative means that f prime decreasing, because we already have such the characterization using the first derivative of f prime. You use the first derivative of f prime, you can see whether f prime is increasing or decreasing. So depending on f double prime positive or negative. That's why we have the concavity test. See, here I write concavity as the noun, right? Not adjective, a noun. If second derivative positive, you have concave up. If second derivative is negative, you have concave down. Okay? So that's the test. And when you have a case, the function change its concavity passing a true point. Khi mà các em có cái đồ thị mà qua một cái điểm, nó từ chuyện là lõm lồi về hướng này, nó lại chuyển sang lõm lồi theo cái direction khác, thì điểm đấy nó có một cái tên. It's called inflection point. Inflection point of a continuous function is a point. Through this point, the concave up and down are changed. Tức là qua cái điểm này thì cái tính lồi hay lõm của cái đồ thị nó thay đổi. What is in Vietnamese inflection point? Do you know? That's right. Người ta gọi đấy là điểm uốn. Correct. Good. Very good answer. This is điểm uốn. Như vậy bây giờ các em đã hiểu cái điểm uốn trong tiếng Việt khi mà các em học ở phổ thông chính là cái điểm mà qua đó cái đồ thị nó thay đổi tính lồi lõm. That's the reason why I explained to the university that sometimes I need talk and explain in Vietnamese. It helps you. You are Vietnamese in general, except some from abroad. Vietnamese students studying in English, but in Vietnamese environment. You are familiar to a lot of words in Vietnamese. Then sometimes if a lecturer explain the name of that or this point in Vietnamese, it helps you to understand better the situation and it helps you to remember better. Okay, such a thing. So it's called điểm uốn. Good. Then we have the second derivative test. You see, the first derivative test means we use the first derivative. But the second derivative, then you have a second derivative test. So second or first, depending on what derivative you use. If you have critical point, f prime of c is 0, and at this point, you have second derivative positive. You know from your high school, then you have the local minimum. But if at critical point at which derivative is 0, you have negative second derivative, then you get a maximum local at that point. So both first derivative for increasingness, which means increasing or decreasing function, or second derivative, talking about the second derivative at a critical point at which the derivative is 0, you can have the conclusion on local maximum or local minimum. Okay, so what happened when f double prime at C is 0? So plus or minus is okay. But in the case f double prime equal to 0, this second derivative doesn't work or inconclusive, give no information. So all what are the same. No information, inconclusive, doesn't work. Only positive or negative double prime of f. At this point, then you can talk about local maximum or local minimum, right? Which means at this point, the point might be maximum. Yeah, we don't know. Might be minimum or neither of these. So for this case, you have to consider separately. You have to investigate separately this point to see whether it is a maximum or minimum or nothing. Okay? So also, this test, second derivative test, fail when you don't have f double prime. Because you need double prime, positive or negative, that is before that you have the existence of f double prime at C. But if double prime at C doesn't exist, then you cannot apply this test. So that's why, again, at this point, I would like to ask you to remember, before apply any theorem, any test, any lemma, any proposition, you have to be sure that you get in your hand own assumption. Tất cả các giả thiết của những cái điều mà các em muốn apply, các em phải có trong tay đã, thì các em mới được apply. Còn nếu các em đã bỏ qua bất kỳ một giả thiết nào, thì cái khả năng các em apply sẽ là sai. Understand? So, in this case, you should not use the second test derivative and you come back to the first derivative test. And very interesting, note that when both tests can apply, then the first derivative test is more or less easier to use, because second derivative you have to differentiate f prime, again sometimes very complicated, especially when you have the ratio. You have ratios, then derivative quite complicated, but derivative, the first derivative equal to 0, you look at the only numerator. You don't care about denominator much, right? Because when you have the ratio, denominator is square. That's the reason the first derivative in general is easier, okay, to use. Now, the last section of today, you can see curve sketching. Tức là gì? Ngô Trần Hoàng Quân, điều này có nghĩa là gì? What does it mean?
Vẽ đường cong ạ.
Yeah. Or we say vẽ đồ thị, tức là in some sense là vẽ. Bởi vì tại sao người ta dùng sketching? Nói cho cùng là chúng ta vẽ ra cũng chỉ là tương đối thôi, chứ đâu ta có vẽ được chính xác. Hình ta vẽ cũng chỉ là tương đối, cho nên người ta dùng sketching, theo nghĩa tiếng Anh là thế. A self-study. What does it mean, Nguyễn Phương Thảo? A self-study. What does it mean? Không ai nghe gì cả. Cái microphone của cô chắc là khó vấn đề rồi. Tức là các em phải tự học, tự đọc, tự học, tự hiểu. Nhưng mà tự này dễ mà. You know from your high school. So that's why I go very fast this part. Okay? I go very fast this part. Trịnh Ngọc Tường An thì viết luôn là tự học. Right. Yes. Correct. You understand this one. So what you have to remember here. Here I explain about the curve sketching, and you need asymptote. Asymptote is the distance between graph and some fixed line. When it approaches to zero, then you get asymptote. Asymptote, there are three possibility asymptote. Vertical asymptote. So what is asymptote? Now let's see. Huh?
Sorry. No.
What is asymptote? What do you think?
Tiệm cận nào?
Cấn Trung Hiếu. What does it mean? Asymptote.
Đó là đường tiệm cận.
Đường tiệm cận. Yes. This is tiệm cận. Yeah. And vertical line means that tiệm cận đứng. Đúng không? When you have this situation, six situation. And then here the so-called explanation by example. What you have the vertical line, right? Vertical line when x tend to something. See, a minus, a plus. You get a plus or minus. You get fx tend to plus or minus infinity. Then you have the vertical asymptote. Yeah, something like that. This one, vertical. And also you have horizontal asymptote. Tức là tiệm cận ngang, kia là tiệm cận đứng. When you look at x tend to infinity plus or minus, you have the situation like that. That one, this one. This is, thì cái này là tiệm cận ngang. Right? Okay. Here you are asked to find the horizontal asymptote. Là đường nằm ngang. Tiệm cận với đường nằm ngang là tiệm cận ngang. Then you look at this situation when x tend to plus infinity or minus infinity. So very easy to do. You know quite well. Look at this example. But this the so-called oblique asymptote. What is that? Tiệm cận gì? Xiên. Tiệm cận xiên. Oblique, remember. Đứng và ngang, vertical and horizontal. But oblique, the xiên. And this one only happen to the case of rational function. Not any function. We can talk about that. Only rational function. Which means this is the ratio of two polynomials. Only in this case, you have an oblique asymptote, and happen in the case the degree of numerator is bigger than the degree of denominator by 1 unit. Only in this case, you have the oblique asymptote. If you don't have this situation, you cannot have oblique asymptote. Well, oblique asymptote is the line y is mx plus b, which means that linear line, straight line. When you have this one, means when you divide p over q, you have mx plus b plus something rx. And this one can have only in the case if degree of p is bigger than degree of q by 1 unit. Then dividing, you can have this part. And rx tend to 0. So you have vertical, you have horizontal, and you have oblique asymptote. You should do, and you should remember for this example also. Okay, here you have, you see, very, very beautiful. This one, oblique, this oblique asymptote, this vertical, right? No horizontal. And the last, some slide tell you how and what you have to do. These guidelines provide all the information you need to make a sketch of a function. So if you have such a question for tutorial, for midterm, for final exam, you should write down all these steps. The first domain, where is fx defined? You should write, right? Otherwise, no one understands. You consider f on what domain, right? Next, intercept. Intercept means that intersection point of the curve and x-axis and y-axis. But remember, y-intercept is easy. You look at fx where x is 0, very easy to add this. But to solve x-intercept, where intersect the curve with x-axis, not easy, which means that you have to solve this equation to find what x are. In general, difficult, right? So that's why I write omit this step or ignore this step or skip this step if a function is difficult to solve. Nếu mà khó quá và nói chung là nó quá khó thì các em bỏ qua cái trường hợp x-intercept này đi và chỉ cần làm cái y-intercept này. Giao với trục hoành khó tìm lắm thì làm giao với trục tung. Thế thôi là đủ. Okay. Next, you should look at whether function is symmetric or not. Cái tính đối xứng gồm có odd, even and periodic. Periodic function you know, right? Hàm tuần hoàn, hàm lẻ, hàm chẵn. Đó. After that, you look at asymptote, horizontal line, vertical line, right? And if possible, the ratio of two polynomials, you can have the oblique asymptote. If f is rational function, right? And after that, you start to look at derivative to see the interval of increase or decrease of this function. So you can use increasing, decreasing test, right? We talk about positive and negative, okay? And from that, you can find the maximum and minimum local by looking at the critical point where f prime doesn't exist or equal to 0, and then you use the first derivative test to find the local maximum, to find local minimum by changing when you passing by the point C from plus to minus or minus to plus your derivative. And also you can use the second derivative to talk about the local minimum or local maximum if it is more convenient. Sometimes it's the more convenient to use the second derivative in case it is easier to compute. If too complicated, so don't do that. Use the first only, right? And the next, you should see whether you have a point of inflection. Có điểm muốn hay không là cái bước tiếp theo. You can talk about concavity, the concave up or concave down, upward or downward. And after A, B, C, D, E, F, G, how many? 1, 2, 3, 4, 5, 6, 7. 7 points in your solution. You have the last point, 8. Sketch the curve. Only after 7 points, you come up to the last final step. This sketch the curve using the information you get on the previous 7 point step, right? So here, for example, you have such a things. Very interesting to try by yourself. Please try by yourself. Use this exercise. I give you the answer. Okay? So, good. We can stop at that point here today. So, in summary, for today, what did you have? For today, what did you have? We look at that at the beginning. Oh. For today's lecture, what did you have? See, you have that part. Okay, so revise when the lecture, and by the end of the week, after giving the lecture, the same lecture for the second group, I will be uploading the summary. Then try to understand, remember the main point of the lecture and work on tutorial. Again, please, all those tutors may not go through all the tutorial. You try to do all and discussing with your classmate, okay, with your classmate. Then you understand better the summary and the content of the lecture and work for the tutorial problem. All try to do and ask your tutor in the case needed, because for the midterm and final exam, I am basing on the tutorial problem to think how to give you the different problem for your test or for your exam. Okay. Những cái gì mà tôi ra cho các em ở trong tutorial là quá đủ để các em ôn tập, vì mỗi một lần tôi ra rất là nhiều. Làm không có nghĩa rằng cứ phải làm hết khi mà các em đến lớp học, nhưng mà cố gắng làm hết, và những gì chưa làm được thì các em nghe, các em trao đổi với bạn, trao đổi với lại tutor để mà nắm được tình hình. Ok. Thế còn lần sau ấy là chúng ta sẽ kết thúc cái chương 3 bằng 3 cái mục cuối: optimization problem, Newton method and antiderivative. So antiderivative is easy, but optimization problem and Newton method very interesting, especially optimization problem. Tôi là một trong những cái người rất thích ra đề ở cái phần optimization problem, bởi vì đấy là cái bài toán nó liên quan đến thực tiễn, real life. Các em phải quyết định xem dùng cái nào tốt nhất, dùng cái nào tồi nhất, dùng cái nào thì tốt hơn cái kia. Và đấy là optimization, tức là bài toán về vận chủ trong thực tiễn. Và optimization problem là toàn là ra theo cách là what problem, tức là toàn bằng lời thôi. Giống hôm nọ cái bài toán về speeding car của Dom Toretto với lại police car đấy, là các em phải hiểu được cái tiếng Anh là người ta nói cái gì để các em làm bài. Ok, so done for today. Thank you for attending. So warning again, cô Lê Linh Chi là hôm nay bật lên xong rồi là đã bật là còn bật to rồi là trốn đi chơi, không có học hành gì cả, gọi không thấy đâu hết. Ok, done. Bye bye.
All right. Bye bye.